Question 1 on the summer test was algebra based. We followed the rules of algebra and algebraic fractions. We multiply the two things on the bottom, whatever they are. X plus 5 by x plus 1. And then we cross multiply, so we get x plus 3 by x plus 1. And the plus sign is in the middle, we get x minus 2 by x plus 5. And this is all equal to 1. And if any fraction is equal to 1, the top has to be equal to the bottom, similar to 7 over 7. So we multiply the top out and let it equal the bottom. So we're going to get x plus 3 by x plus 1 is x squared plus 3x plus x plus 4x plus 3. Then we're going to get plus x squared plus 5x minus 2x, so plus 3x minus 10 will be equal to the bottom, which is x squared plus 5x plus 1x plus 6x plus 5. We cancel the x squareds and simplify. We just have 1x squared. Our x's, we have 4x plus 3x is 7x, and then we have minus 6x, so we're going to get 7x minus 6x is plus x. We have a 3 and a minus 10, so we have minus 7, and we're bringing over a minus 5, so that will be minus 12. Equals 0 left on the right. You can see that this factorizes straight away. And we have a 1x in the middle and a 12, so it has to be a 3 and a 4. We want plus 1x, so plus 4x minus 3x. So x is equal to minus 4 or plus 3. And we may as well check that both these solutions work. They don't always work, but let's have a look here. We put minus 4 in for x. We're going to get minus 4 plus 3, which is minus 1. And minus 4 plus 5 in the bottom, which will be 1. And we're going to get plus minus 4 minus 2 on top will be minus 6 over minus 4 plus 1 will be minus 3. So it's going to give minus 1 plus 2, which is in fact equal to 1. So x equals minus 4 definitely works. And what about x is equal to 3? We're going to get, putting in here, top fraction, 3 plus 3, 6, over 3 plus 5, 8. Then we're going to get plus, putting 3 in here, 3 minus 2 is 1, over 3 plus 1 is 4, and 3 quarters, which is 6 over 8 plus a quarter, is equal to 1. So both solutions work for part A. For the simultaneous equations, we have a linear and a non-linear, so let's write x is equal to 3 minus y, or y is equal to 3 minus x. So we get x squared first. X squared is going to be 9 minus 3y twice plus y squared. And then let's write this expression out again. Instead of x squared, we have 9 minus 6y plus y squared minus 3y squared. And I'm going to bring the 13 across. Minus 13 is equal to 0. So we're going to get minus 2y squared. We're going to get minus 6y. And we're going to get minus 4. And if we change or multiply by minus 1 and divide by 2, we're going to get y squared plus 3y plus 2 is equal to 0. And you can see this factorizes quite quickly. So we have a 2 and a 1, and they're both pluses. So y is equal to minus 1 or minus 2, and x is equal to 3 minus y, so x is equal to 3 minus 1, so 4. So off to the side, keep it nice and neat. The second one is x is equal to 3 minus 2, so x is equal to 5. And we could write these out at points 4 minus 1 and 5 minus 2. Your knowledge of logs here. When we add logs, it's multiply. When we take away, it's a divide. So log to the base 2 of x plus 2 by x minus 2 will be equal to 5. Rearranging, we get 2 to the power of the answer on the right hand side. 2 to the power of 5 is equal to x squared. The minus 2x and plus 2x will cancel, so we have x squared minus 4. 2 to the power of 5 is 32. That's equal to x squared minus 4. So we get x squared is equal to 36. So x is equal to plus plus or minus 6, but the minus doesn't work here. X is equal to 6 for your log question. Part D was an indice question. Change 8 to 2 to the power 3 over 2 to the power of x. 32 is 2 to the power of 5. So we have 2 to the power of 3 minus x is equal to 2 to the power of 5 using the rules of indices. So 3 minus x is equal to 5. So x is equal to minus 2. And if you wanted to check that, you could put on your calculator 8 divided by 2 to the power of minus 2. That will give you 32, or 8 divided by a quarter. Third equation, square both sides. X squared is equal to x plus 2. So x squared minus x minus 2 is equal to 0. Factorizing, we get x times x. We have to have a 2 by 1 to get 2. And we have minus 2x plus 1 to give minus x. So that would mean that x is equal to minus 1 or plus 2. And in third equations we do have to check. So is minus 1 equal to the square root of minus 1 plus 2? You can see that square root, we can't get a negative. So no. Is 2 equal to the square root of 2 plus 2? 2 is equal to the square root of 4. Yes, it is. Third equation's done. And finally in algebra, the rules of inequalities. So we multiply by the bottom squared, so we get x plus 3. We'll do it the long way, over x minus 4. So we don't know if the bottom's negative, so we got to square it. So multiply by x minus 4 by x minus 4. Less than minus 2 by x minus 4 by x minus 4. You could skip putting the 2 in on the left, but we're going to have x squared, x plus 3 by x minus 4, x squared minus 4x plus 3x, minus x, minus 12, has to be less than minus 2 times, don't try and do it too quickly, x squared minus 4x twice, and then minus 4 by minus 4, take my squared, so we get x squared minus x minus 12 less than minus 2x squared plus 16x minus 32. Bringing everything to the left, we're going to get x squared plus 2x squared, 3x squared minus x minus 16x minus 17x, and minus 12 plus 32 will be plus 20. Will have to be less than 0. We're told x is not equal to minus 4, so we'll see in a minute if this comes in. Does a minus 4 come in here? 3x times x. It's the only way to get 3x squared. It's probably 5 by 4 when we have a 20. So 5x and 12x is 17x, both minuses. So if we graph this solution, x is equal to 5 over 3, would make it equal to 0. To make it less than 0, x is equal to 4, which it can't be. So our solution here is that x will be less than 4 and greater than 5 over 3, greater than or equal to. So if we graphed it, it would look like this, both positive, and the y-intercept is 20, so coming down something like this, going up. It's going to be the solution will be in here, 5 over 3 and 4. So that's the end of your algebra question. You need to practice these if you're not good at them. 5 or 6 different topics within one question.